Yeah, good morning to all participants and a warm welcome from my side. My name is Frank Reps. I'm part of the marketing team responsible for equipment and instruments in Europe. And welcome to our webinar today, hosted by ICA. Our topic today is Rotary Evaporators, how to increase efficiency in your lab, and congrats for joining us today. Before we start, just to share a couple of housekeeping notes with you. You can raise questions during the webinar. While you are muted, please use for that aim the question area. Please raise your questions. Don't hesitate to ask you anything about any content you will see in the next couple of seconds. We will take care and appreciate any questions you might raise. You don't have to write something down. So you will receive a follow-up mail right after the webinar, giving you all the informations, including the recordings of the webinar. So there is no real need to write some notes in parallel. And the webinar itself, if you think, oh, my colleague might be interested to have that information as well, share with him the link, because the recording will stay at uwr.com in the webinar section for at least 1 year. So the content will be available for 12 months. So if you want to share, I can encourage you to do so, and you'll find them back on our webinar homepage. So having said that, I hand over to Andreas Vogel from ICA. And thanks, Andreas, for giving us the training and all the insights about how to increase efficiency in your lab by using a Rotary Evaporators, and sharing all your tips and tricks doing so. The stage is yours, Andreas. Welcome.
Thank you very much. Thank you very much, Frank, for the introduction, and welcome everyone also from my side. Maybe just some words to myself. So my name is Andreas Vogel. I'm a chemist, studied chemistry in Freiburg in Germany. And I did a PhD in chemistry as well, where I did some synthesis on sustainable fuels. So I'm used to organic synthesis as well as inorganic synthesis, and also used a lot of rotary evaporators in my PhD and my studies. And now I'm responsible at ICA in the product management for rotary evaporators, as well as our reactor systems and laboratory software. So welcome everyone to today's webinar. Today is all about rotary evaporators and how to increase the efficiency in your lab. And we will directly start, just that I also know you and your background a little bit more, with a short poll, just to see if you're already using rotary evaporators in your lab, or if you're not using them at all, or if you plan to use them. So it would be great if you could just do the poll, that I'm just know your background a little bit more.
I just shared the poll, Andreas, so please vote if you're already working or not with a rotary evaporator. So, it's picking up. Let's give another couple of seconds, but the result is already clear, Andreas. Over 80% are currently using a rotary evaporator, and less than 20% are not using a rotary evaporator. So I think we can close that. So 80-20, typical.
Okay, perfect.
Thanks for voting.
Yeah, thank you very much for voting. It's always interesting just for me that I know where to start, and also to know a little bit more about the audience. So we will do a short introduction. So for those of you who already know rotary evaporators, it could be well known, but maybe for those of you who don't use them at the moment, it would be interesting just to have the basic principles of a rotary evaporator. So you can see here in the picture, we have two basic principles. We have the evaporation and the condensation. So what you're actually doing is you have an evaporating flask, and inside this flask is placed inside a heating bath, and this heating bath has a constant temperature. So we at ICA always recommend to use 60 degrees, but the most important point is that this temperature is constant. So you evaporate your liquid, which is inside the evaporating flask, and the liquid will evaporate. You will get vapor, and this vapor is condensed on this condenser here. it will be liquid again, and you can receive it in the receiving flask up here. So now maybe you think, okay, if we always have 60 degrees in here, how can we do the evaporation for all the different solvents? So that's why we have an adjustable pressure. So maybe you think about water. So if you think about water, we have different boiling points depending where we are on Earth actually. So for example, if we are on the Mount Everest, which is really high, then we have a lower lower pressure, and this is why we have a lower boiling point. So the boiling point is dependent on the vapor pressure, or on the pressure at your area, or how we will do it with the rotary evaporators. We will have a vacuum pump which adjusts the vacuum. So we can adjust the pressure, and with this we have the possibility to always keep the heating bath temperature at the same temperature and just adjust the vacuum or adjust the pressure to get boiling inside our evaporating flask. So what are the 5 main features of a rotary evaporators? We have a rotation, so we have to rotate this evaporating flask. With the rotation, we will get a thin film on the surface of this evaporating flask, and we get a really nice evaporation without boiling of this solvent. We also have a lift operation, so you can just move this lift up and down, so to get the evaporating flask inside the heating bath or to get it out of the heating bath. Of course, very important is the heating bath itself, so always to have a constant temperature, that's very important, and of course the vacuum control. So we have to control the vacuum to get this boiling point decrease and to get a nice condensation, to a nice evaporation and condensation on the other side. So that's the 5th function of the evaporator. So this was just quick introduction. Now I just want to clarify the setup, that you just know what I'm talking about if I talk about the different parts of the rotary evaporator. So we have always the condenser. That's the condenser. We have here a stopcock where you can also, which you can also use to refill. I will also show this to you later. We have a vapor tube, which is also very important. It connects the evaporating flask with the condenser. Here we have the receiving flask where the liquid is received after the evaporating process, the heating bath, the evaporating flask, and of course here we have a drive which is able to rotate the evaporating flask. Just that you know all the names, what I'm talking about in the next slides. And now I just want to dive into some known problems and how you can solve them, because today's topic is how to increase your efficiency. And for this, I would also like to do a short poll, just also to get your feedback, to know what's your background. So the next poll would be just what is your background? Maybe you are a chemist, maybe physics or biochemistry, pharma, or maybe something totally different. So I would just be interested in your scientific background. Maybe you can just also do the poll.
Yep, it's open now, Andreas.
Perfect.
So let's see on what we go more specifically in. Okay, that's roughly 60% chemicals and 15% coming from the biochemistry sector and 24% others. So I will close the poll now. So chemistry and biochemistry.
Okay.
Thanks for voting again.
Yeah, thank you very much for voting. So because it's really interesting, because these rotary evaporators can be used in so many different applications, but I also think the main application will be the chemistry sector, where you have solvent recovery, where you can just get rid of your solvent after reaction. So I think I've also thought that this would be the main background is chemistry. So now let's dive into some problems. So maybe if you are using a rotary evaporator at the moment, then you know that sometimes you will not reach the end vacuum. So you have a good vacuum pump, but actually you're not reaching the end vacuum. And what reasons could this have? So of course, it could be that some connections are not tight. So this means you always have to check all your connections. You can also see this here. We have here, for example, GL fittings. So these GL fittings can be untied. So you have to check these as well. Always check if this vacuum cock, the stop cock is closed. And of course, if you have ground joints, and normally all of these connections here are with ground joints, I always recommend to use some grease just to get a good sealing and to get a good connection and a tight connection. I think this one is just like the first one, what you maybe also thought about, but of course what could also be a problem regarding the vacuum is that the sealing, which seals the vapor tube, which is inside here from the condenser. So this sealing will be here. This can also be damaged and maybe has to be replaced. So this is a PTFE compound which have to be replaced time by time. So just that you are also aware of this. So if all connections are tight and you're not sure what the problem may be, you can also check the sealing. Maybe the sealing is not tight or it's just damaged, and you can replace this as well. Another point which is also really often a problem is that solvent was sucked into the vacuum pump. This means, and this is what I would really recommend, before you check all the different connections, because you can see we have a lot of different connections having these GL fittings, this vacuum cock. Here you have a connection, you have some tubes to the vacuum pump, you have this connection here. So there are many different possibilities where leakage could be. But at first, I would always recommend just to check the vacuum pump first. If the vacuum pump itself can just reach the vacuum. So how do you do this? Quite easy. You just take off the vacuum tube, which is placed here on top in our rotary evaporators. Take the vacuum pump, put on your finger, and just see if you reach the final vacuum. You can just take your finger, or you can just close the vacuum tube differently, just that you can be sure that the vacuum pump works well. But because maybe it could be that just the solvent is sucked into the vacuum pump, and that's why the membrane is blocked. The membrane in the pump is blocked with solvent, and that's the reason why you don't reach the good vacuum. So that's also the next point. What do you do if solvent is sucked into the vacuum pump, and how can you be sure that you will just not even get solvent sucked into the pump? So how will this happen? I just tried to illustrate it here, so you can see if you have if the vacuum value is too low, you get the condensation will not stop at the condenser, but you will also get some vapors inside your pump directly, because if the vacuum value is too low, you get a too high evaporation, and the vapor will not only condense on the condenser, but like you can see it here, it will also go higher. Not even the highest of these coil will be possible to condense the liquid, and the liquid or the solvent will go inside your vacuum pump. So this means the condenser cannot completely condense the steam. So how can you do this, that you will completely condense the steam, this condenser? You just increase the vacuum value. It's as simple as this. So sometimes, of course, time is money, and you just always want to be as fast as possible. However, if you have a too low vacuum value, the condenser it's not possible for the condenser to condense all of your vapor. It will go inside the vacuum pump. So what you have to do, increase the vacuum value, then the condensing will be not that high anymore, and it should always reach like 2/3 of this condenser. That's enough. So you shouldn't go higher than this. Then you can really prevent. That's one way to prevent solvent be sucked into the vacuum pump. Another way is just to use a different kind of condenser, which has a higher cooling surface. Because if you have a higher cooling surface, then you also have the possibility that you have a higher cooling surface. You can also decrease your vacuum value, which means you get a faster evaporating process. And what's really important, you can see this in this picture, there are many different condensers on the market. Our condenser here at ICA, that's a really special feature here, and it doesn't matter if it's an ICA condenser or any other condenser. If you have these problems, just have a look that you avoid the stack effect. Like you know it maybe also from a chimney. if there is nothing inside, so here we have a coil inside, if there's nothing inside, the vapor would be just so fast that you will not avoid that some vapor will go inside the pump. So what you will do, or what we always recommend, to use such a kind of condenser which avoids this stack effect. And with the avoidance of the stack effect, you can also go lower in vacuum, because all the vapor can condense inside your condenser, and you get a really nice condensation without getting solvent inside your vacuum pump. However, of course, it can always happen that some solvent is inside a vacuum pump, and how can you clean this vacuum pump? Here we have the possibility to have an automatic cleaning function. We always recommend after an 8-hour usage to clean the vacuum pump for 30 minutes. And that can be done manually if you just use a cleaning function, or for example with the Vexer Digital from ICA, you have the possibility to clean the vacuum pump automatically. So you can just tell the rotary evaporator or your vacuum controller that it should always clean after, for example, 8 hours, so you don't have to think about this anymore. So the membranes, so it will just run using air, so instead of sucking from the atmosphere of the evaporator, it will just suck in some air. This will clean the membranes again, and you will get the good performance back of your vacuum pump. All right, so this was just the first example. So that's also how I build up the whole presentation. I just want to focus a bit on some problems which you may be facing in your daily life and how we can solve them. So the next problem you may know is if boiling solvent splashes into the receiving flask. So here is just in the picture that you have an idea what I mean. Sometimes you just always everything has to be fast, so you just want to decrease the vacuum value very, very fast, and this could happen that some solvent is overboiling and splashes directly inside your receiving flask. And of course, that's a problem because you want to separate different solvents or different liquids and solids from each other. So that's really a problem, because then you have to restart your process. So what are the reasons? Sometimes you have a boiling retardation. So especially if you're using water, the water has a really high boiling retardation. So this means you go down with the vacuum value, everything looks fine, and at one point it just starts to boil directly, and everything splashes into your receiving flask. And of course, that's not what you want to have. So if this happens, of course, the vacuum value is too low. So you reduce the vacuum value too fast, and that's what you have to avoid. However, if this happens often to you, we also have an accessory. It's a foam breaker. You can see it here. This foam breaker is quite simple piece, just a glass piece, which can be used in combination with the evaporating flask. So you just put this on top of the evaporating flask, and if this would happen with overboiling, you would have the possibility that the solvent is not directly going inside the receiving flask, but it will go first inside this foam breaker, and you have the possibility to just avoid that all your substance, your product or your reaction solution will go inside your receiving flask. Another possibility how you can avoid this is by using an automatic boiling point detection. So for example, with one of our rotary evaporators, you have the possibility that the rotary evaporator itself will recognize the boiling point. So what you are actually doing is you just press start, the vacuum goes down very slowly, and just always checks if your solution is boiling. So how is this done? I just want to explain it to you to give you some more insights in this webinar. So it works like this on the back of the evaporating system. So if you look here on the back of this, you can see this setup. That's just the cooling water which goes inside the condenser is measured. The temperature of the cooling water is measured with these two sensors. So we have one sensor for the cooling water before it enters the condenser, and one sensor after the condenser. And then we have the possibility to check the temperature difference between the water or the solvent, the cooling water before the condenser and after the condenser. And with this temperature difference, we can determine if your solution is boiling at the moment. And that's how we can manage, because we can control the vacuum automatically. That's how you can manage to get a really nice evaporation without overboiling. So that's just how you can prevent this, by using this automatic boiling point detection. So that's also independent of the solvent. So you don't need to insert, or you don't need to define the solvent which you're using. You can just directly press start and everything is done by itself, by the rotary evaporator itself. What else could be a problem? So many users for just a few rotary evaporators. Probably every one of you knows this problem, because normally not every user in the lab has his own evaporator. So how can you handle this? And also here, I would recommend to use the automated systems. So maybe you think now, why can this improve our workflow? With the automated systems, like I just explained to you, you can just start the distillation automatically, and the rotary evaporator with the same principle will recognize the end of your process, and it will detect the end. And that's quite simple, because we always measure the temperature difference between the cooling water in and out. And then we know, okay, if the temperature difference decreases again, all of your evaporating process is finished. And we have the possibility, or you would have the possibility, to just define actions after distillation. And these actions after distillation can be, for example, an acoustic signal. You can vent your process, and you can rise the lift. So how does this save your time? For example, if you have many users for just a few rotary evaporators, you have the possibility to use this automatic distillation, and everyone in the whole lab will directly hear and see when the evaporating process of the colleague is finished. And then you can just directly go. You don't have to, because I don't know how you're doing it at the moment, but when I was in university, we had like 4 or 6 rotary evaporators for like 20 people. And you always had to go there and look, is the process already finished? How can when can I go to this rotary? When can I use this rotary evaporator? And this just gives you the possibility to directly see and hear when the process of your colleague is finished. So you can really save time by reducing the downtime, because you don't have to go there. You can just directly see and start your new evaporating process. All right, so these were just some problems you might facing. Now I would, in the next slides, I would go a bit deeper into some applications. And I would also like to start this new topic, applications, with a short poll. So the next poll would be, for which applications do you use your rotary evaporators? Maybe solvent recovery, product isolation, maybe if you do like chromatography before this, organic synthesis, this could be both, or maybe some totally different applications. So maybe you can just vote. I think it's already available.
Yeah, it's live, Andreas. Just results coming in. So let's give another couple of seconds. Okay. It's more or less a clear picture. 60% are voting for the product isolation. And then we have roughly 20% for solvent recovery, which is an important one as well, I guess. And 16% are others, while 6% doing organic synthesis. So more than 60% product isolation, roughly 20% solvent, others, and 6% organic synthesis. Thanks again for voting here.
Thank you very much for voting. Yeah, I think that's very interesting, and that's also what I thought, because I think product isolation and organic synthesis are like hand in hand to each other, because normally you isolate your product after your organic synthesis. I think most of most of the syntheses are organic, because just organic solvents are really quite nicely to use with rotary evaporators. And I think this product isolation is yeah, very important step, because you can just easily remove your solvent and have the possibility to just isolate your product. Okay, thank you very much for voting. So maybe some of you are facing, if you do like organic synthesis, maybe you will not even have so many viscous or sticky samples, but it could also be interesting what I would just like to show you. So especially if you have like viscous or sticky samples, it could be that your sample will just be inside the, will just stick inside your evaporating flask. And there's a possibility to get this out, because if you just want to remove a solvent, or if you just want to dry high viscous material, then we have the possibility to just use these evaporating cylinders. I don't know, maybe you already know them, but they are quite nice, because you have the possibility to remove the lid, and you have this big cylinder in here where you can just fill easily in. So you can fill it easily, and you can of course also remove everything easily by using, here we have the laser pointer. Oh, sorry for this. Yeah, now we have the laser pointer again, and you can use this easily for refilling, for filling, and also of course you can use it if you want to just fill in your samples. Maybe you also, especially if you use it for product isolation, the rotary evaporators, then you are probably, or some of you will maybe do like column chromatography after your organic synthesis. And then you probably also use that to this problem that you want to concentrate your liquid, because you have like a really big flask. It's like maybe 1 liter or even more than 1 liter, but your actual product is not just the last 30 or 50 milliliters. So how can you concentrate the liquid? So you start with very high volumes, but you actually, it's when you just always continue with the same evaporating process with the same flask, and it's difficult to remove the sample afterwards, because you have such a big flask and it's just like 40 milliliters of samples, and you have to refill some solvent, and that's always not that nice. And it's also time consuming to check, because we always recommend, and probably that's also how you learned it, that you should replace the big flask with a smaller flask at some point, just to get a really good evaporating process. But now, how can you increase the efficiency? Here, you can use the volume control distillation. That's a patented function which we have at our RV10 Auto Pro. That's our rotary evaporator system. And what does it do? You have the possibility, you determine the solvent. So for example, you have, I don't know, dichloromethane or another kind of solvent. You can just, there's a big solvent library, more than 40 different solvents can be chosen. And with this, you have the possibility to tell the system how much volume should be distilled. So for example, you probably know you will have at the end of your process, you will have like 100 milliliters or 50 milliliters, and then you would like to have to change the big flask to a small flask. And with this volume control distillation, you have the possibility that you tell the system, for example, you have a 500 milliliter volume, and you just tell the system, okay, please distill 400 milliliters, and then it will, like we've seen it before, it will automatically stop, it will vent, it will go up, you will have this acoustic signal, so you don't have to go all the time to the rotary evaporator to check what is the actual distillation, where is your distillation at the moment, do you have to refill, so, you know, you always are a bit stressed maybe because you always have to check. So you don't have to check anymore, because if the system is finished, it will just directly move up. You will get the acoustic signal, and this gives you the possibility to save time by just changing the evaporating flask at this time after you've seen or heard the acoustic signal or seen this lift operation. So this gives you also the possibility to detect the end of the process and to increase the efficiency by saving time. Another possibility, which could also be interesting, also if you concentrate liquids and you don't want to use this high performance rotary evaporator just because of budget, you also have the possibility to refill your evaporating flask, because maybe you've taken too much solvent and you would like to refill again because, for example, your solid is precipitated, or you just need to refill your reaction mixture. And that's also possible while the distillation. So how do you do this? You can also see this inside in the picture here. So what we have, we can just use a beaker, or you can directly use the solvent bottle. You can just connect the tube in here. And like you can see it in this picture, with every standard glassware of our rotary evaporators, you will have a PTFE tube included. And this PTFE tube goes directly inside your evaporating flask. And you have the possibility, just by opening this stopcock, to suck in the solvent. So you can refill while distillation. And this gives you two possibilities. So either if you distilled too much liquid and you actually would like to have a bit more to replace it inside another flask, for example, or if you just want to do continuous distillation. So there are also bigger rotary evaporators where you can place, for example, 3-liter flask, 5-liter flasks. But I don't know if you've ever handled a 5-liter flask with organic solvent. I would not recommend to do this, just because organic solvents or even your reaction solution will be quite toxic. So what I would recommend, I would just here use a smaller evaporating flask, use a big receiving flask, like 3-liter receiving flask, and then just refill all the time. So then you can just refill. You don't need to have this, you don't need to stop even the evaporating process. You can really do it while this evaporating flask is inside the heating bath. And this gives you the possibility to have a semi-continuous distillation. All right. So the next topic would be, how can we save the environment and also the user when you're using rotary evaporators? And for this, I also have a short poll where I would like you to vote again. In which industry do you work? So we know now that most of you are chemists or chemical background, but what is the industry you're actually working? Chemical, pharmaceuticals, maybe teaching in like universities, food, or maybe something totally different. So it would be great if you could just vote.
Yeah, coming up, Andreas. Just give another second. But I think, as you might guess as well, over 40% are coming from the chemicals area, followed by food, 14%, 9% teaching, and 3% pharmaceuticals, and 30% are working in different areas and with different applications.
Oh, that's also interesting. Yeah, thank you very much for voting. Also interesting that there's so many different industries, of course, where you also use the rotary evaporators. And yeah, chemical industry, I think, is also very big regarding rotary evaporators. Yeah, thank you very much for voting. So now the topic is, how can you save or protect the user? How can you increase your efficiency? And there I would just go a bit more into vacuum. So there are actually two different possibilities. You can either use, maybe some of you will just have house vacuum, and then you have a vacuum controller, and this vacuum controller is just valve regulated. So there's a difference between a valve and a speed regulated vacuum pump. So valve regulation, you can also see this in this picture here. We have here on the y-axis the pressure and the time. And if you just want to have an evaporation and you have a valve regulated, you can also see it here, valve regulated vacuum pump or vacuum controller, then it will look like this. This is your target pressure, which you actually would like to have for the best evaporating process. But what is actually done is that the pressure always changes by time, and that's because you just have on-off regulation. So it measures the pressure. You have a valve, and it will just go on and off. So it will suck more vacuum, then it will go down, then it recognizes, okay, I'm too low in vacuum, it will go up, it will get some air again, and then you will always do it like this. So what is your recovery rate? So this means, especially if you want to distill some solvents, for example, the recovery rate tells you how much of the solvent is recovered. So the recovery rate, if you're using a valve regulated vacuum controller, will be not that good, because you can see how you're actually not using the target pressure all the time, but you're just always close by, but actually not having this target pressure. So if you have a fully automatic control with a pump speed adjustment, this means you have a vacuum pump which is speed regulated, and also a vacuum controller which really regulates the speed of the pump. So this means, if we have a look again on the picture here, then you can see what will be done. You will directly go to your target pressure. You will hold this target pressure for the whole evaporating process, and afterwards you vent again. So here you have a really continuous evaporation instead of this intermittent evaporation, because you're always underneath or over the actual target pressure. And this gives you a really good recovery rate. Furthermore, you also have the possibility with this higher recovery rate, with the speed regulated vacuum pump, you have a lower noise level, because what it actually does is that the vacuum pump doesn't have to go full power all the time, because if you reach the vacuum which you want to reach, it can just stop, and if it goes a bit over the actual target pressure, it will also suck again. So it will just be turned on if it's actually used. So this means you also have a really lower noise level, because the vacuum pump, you will not even hear it anymore at this target pressure, because it doesn't have to do anything anymore. And of course, you will also have a lower energy consumption, because your vacuum pump doesn't have to be full power all the time, because these full power vacuum pumps, they always have to use these valve regulated vacuum control. So this just as an insight that you can really increase increase your evaporating process by using a speed regulated vacuum pump with a speed regulated vacuum controller. Energy saving is of course also very interesting, especially nowadays, because everyone wants to be needs to be environmentally friendly. We have targets to achieve less carbon dioxide formation, so we also need to save energy if it is possible. And the problem is, sometimes you also use these rotary evaporators, but you have a lot of downtimes in between, where the heating bath has its reached temperature, the chiller is turned on, but you actually not even need it. So we also have the possibility to have a device-to-device communication. This means the rotary evaporator can regulate the chiller and also the heating bath. So you can determine if the heating bath, for example, should be switched off after your distillation process, because you know you will not need it for the next hour because you have a break, for example, or you can say, okay, I will use it afterwards again, so I will just leave it on. So this just gives you the possibility to save energy by reducing your power consumption, by having this device-to-device control, and by the regulation of the rotary evaporator of your heating bath and also your chiller. And of course, not only this is possible that you regulate the chiller, it's also possible that you not just use one chiller with one rotary evaporator, but to combine multiple rotary evaporators with a single chiller and a single vacuum pump. And of course, that's also nicely possible. You can see here a setup, for example, with 2 rotary evaporators, but just a single chiller and a single pump. That's of course also possible with more than just 2 evaporators. So for example, if you have a special application, we can also talk about this afterwards. That if you want to have like more than 2, you just need to have a more powerful chiller, for example, or even a more powerful vacuum pump. But this of course gives you also the possibility to save space in your lab, because you don't need to have like multiple chillers and multiple vacuum pumps. And of course, it also saves energy, because you don't need to have like multiple devices running all the time. So this is the last slide from my side. It's about user protection. So we talked a lot about a solvent which can be sucked inside the vacuum pump. And we talked about how you can avoid this by using this automatic cleaning function, for example, or by using a better condenser. What's also possible, and how you can just save the user himself, is by using an emission condenser after the vacuum pump. How does this work? Quite simple. So the vacuum pump always sucks in to get vacuum, and after the pump, of course, the air has to go somewhere. And you have the possibility to connect this emission condenser after your vacuum pump. And inside this condenser, you can just connect the cooling water, the same cooling water which is also used for your rotary evaporator. So you don't need to have an additional chiller or something like this. Use the same cooling water. The vapor which comes out of the vacuum pump can condense here, and it will just go inside this receiving flask, and you can just always remove this. And this gives you the possibility to protect the user, because maybe just think of your solvents which you are using at the moment. Most of them will be toxic, and this just gives you the possibility that you condense the vapors which would otherwise just directly come out either in the fume hood. Then it's okay, not that good, because you are in the fume hood sometimes as well. But if they are not even in the fume hood, but in the room, you will really have the possibility to protect the user by using this emission condenser. And of course, we didn't talk about this until now, but I have to mention this. We always recommend to use coated glassware. So coated glassware means that you have a coated condenser, coating receiving flask. We also have coating evaporating flasks. And this is just because you're always using vacuum when you use a rotary evaporator, and you of course don't want, if there are some damages inside the glass can break, and you just want to save or protect the user from shattered glass. And this is just possible. It's quite simple. Just use coated glassware, so the glass will not shatter in like 1,000 pieces, and then you will just save the user with this. So yes, I think with this presentation, with this webinar, I just wanted to give you some insights about some problems you might facing, also how you can increase your efficiency, how you can also increase time and energy saving. I hope this was interesting for you. And now I would just also hand over to Frank, and we can also have some questions and answer session. You can just use the questions for this.
Thanks, Andreas. I'm just checking back on the question area. Just give me a second to check on that ones. So don't hesitate to raise your question even. So to now, I did not receive any. That gives me the hint to tell you that if your question might appear after our webinar, there is no problem at all. You can raise them anytime using the email address webinar@avantorsciences.com or contact your local Avantor or ICA product specialist. So if some questions coming up after the webinar, which I can imagine, because we talk daily work, Andreas, so question will come during daily work, that's for sure. But I don't see any question. appearing here. So that gives me as well the possibility to thank you all for participating in our webinar today. As said before, you will receive quite soon the recording together with a small survey and all materials which were shared in that presentation and in the training. With that, I like to thank you, not only our participants, but also Andreas from the company ICA to give us all these practical advices, all these insights during that webinar. And as I said before, if any question might appear, don't hesitate to raise them using our email address or to Andreas. Thanks again for joining, and I will close the webinar now. Thank you and goodbye.
Thank you. Thank you. Bye-bye.